All right, hello everyone. So today we'll talk about IAM basics. Okay, so let's talk about what will be the agenda for us today, and then we'll begin quickly. So today's agenda will be talking about introduction to IAM, that is Identity and Access Management. We'll have some IAM basics, then we'll understand AWS account root user, then we'll understand users in IAM, groups in IAM, roles in IAM, what are the benefits of using an IAM role. Then we'll talk about policy in IAM, and we will also be talking about IAM policy evaluation, reviewing the permission or policy, and then we will talk about some of the IAM best practices followed by the conclusion. Okay, so let's talk about a little bit on introduction to IAM. So IAM, as I mentioned, stands for Identity and Access Management. So imagine your digital world as a castle full of treasures. That is your data and applications. So IAM is like a magical gatekeeper standing at the castle entrance. Now, why it matters? So IAM makes sure that only the right people can enter your castle and do specific things inside. So it's not just about the people. IAM also stops any sneaky characters trying to break in. So IAM, as I mentioned, is a virtual gatekeeper and ensures that secure access to the AWS resources. Okay. Now let's talk about little bit more on the IAM part. Okay. So then next is in the world of clouds where your digital castle floats, security is super important. So IAM gives you the power to decide who gets the key to your castle, like having a digital bouncer at the entrance. So imagine a picture-friendly gatekeeper, that is an IAM at the entrance of a castle, checking who is allowed in. So IAM is a web service that helps you securely control access to the AWS resources. So you use IAM to control who is authenticated, that is signed in, and authorized, that is who has permissions to use those resources. So think of IAM as the tool to centrally manage access to launching, configuring, managing, and terminating your resources. You have granular control over access permissions. This control is based on resources and helps you define who has permissions to which API calls. Moving on further, let's talk about little bit on the IAM basics. So IAM, as I mentioned, stands for Identity and Access Management. It is a fancy term for controlling who can do what in your digital world. It's like having a VIP list for your digital space, making sure only the invited guests get into the castle. So IAM has some important friends, that is users. So these are the individual who want access. Groups, think of them as the digital clubs where you can put users with similar needs together. Then we have something called as the roles. So roles are nothing but the special hats that the users wear or even the services wear for performing the specific tasks. Policies are nothing but the rule book deciding who can do what. Now, why it matters? So IAM isn't just a fancy term. It's your digital bodyguard. By managing users, groups, roles, and policies, IAM keeps your digital space organized, secure, and compliant with the rules. So imagine a digital space with users, groups, roles, policies neatly organized and controlled by IAM. Okay, let's talk about IAM root user account. So when you first create an AWS account, you begin with a root user. This user has complete access to all AWS services and resources in the account. So access the root user identity by signing in with email address and password provided when you created the account. So AWS strongly recommends that you not use root account credentials for day-to-day interactions with AWS. You create IAM users for everyday tasks, and you can manage and audit IAM users with the relative ease. So use IAM to create additional users and assign permissions to these users following the principle of least privilege. So you also grant users only the level of access they require, nothing more. And if an IAM account principal, which we will discuss later, needs more privileges, you can add them. Likewise, if you need to remove or revoke privileges, that can be done with a minimal impact on an environment. All right, let's move on further and talk about users or the principal in IAM. Okay, so what are the users in IAM? So imagine your digital castle. So in IAM, users are like important guests at a fancy digital castle. Each user has their own set of keys, giving them access to specific areas. And for VIP treatment, users are like VIPs. You get to decide who gets VIP access to your digital party. So think of creating a user as sending out exclusive invitations. So you choose who is on the guest list and what they can do inside. You can create the users. So creating users is nothing but digital party invitations. So creating a user is like preparing invites for your digital party. You are the party planner and deciding who is invited and what they are allowed to enjoy in your digital space. Then comes is managing and customizing the access. So think of dinner table seating. Just like arranging seats at a dinner table, you can organize what each user can access. It's about controlling who holds the keys to different rooms in your digital castle. Then comes is the principle of least privilege. It's like a cool security rule. So IAM follows a cool rule called the principle of least privilege. Imagine it's like saying only give the necessary keys to each guest. This keeps everything safe and in order. Imagine picture users as VIP guests holding different keys and each key granting customized access to the digital castle. So by default, the new IAM user has no permissions to do anything. The user is not authorized to perform any AWS operations or access any AWS resources. An advantage of having an individual IAM users is that you can assign permissions individually to each user. All right. So now let's talk about groups in IAM and what are those and what we can do with them. So think of digital teams for smooth sailing. So creating digital teams, that is making your digital world organized. So digital teams in IAM is nothing but imagine groups in IAM as forming squads of digital friends with similar roles or needs. It's like creating teams for your online buddies, keeping everything organized. So efficiently organizing users is like seating people with similar interest at the same table. So groups act like tables, bringing users together based on what they are into or what they need to access. Then it also does the simple permission management task for us. So permission management might sound complicated, but with groups, it's a piece of cake. It's like giving one set of keys to the whole squad at once, making it easy to decide who can open which doors in your digital world. So you can also imagine or you can visualize users organized into the different groups and each group having a shared set of keys for access. All right. So then moving on to the concept of roles. Think of roles in IAM to be the shape shifters of digital authority. Now, what are the purpose of the roles? There are three different things that we can do with IAM roles. Let's first talk about the definition and the purpose. So roles in IAM are like special hats the users wear for the special or specific tasks. So they have a purpose, that is granting temporary permissions for certain actions. Now, how roles differ from users or groups? So unlike users and groups with fixed access, roles are more like temporary superheroes. They only wear their special hats when needed, giving them the power to perform specific tasks. Some of the use cases for roles include roles typically shine when, especially in cross account access. It's like borrowing a friend's special skills. So imagine needing access to another digital realm. Roles make it seamless and secure process. You can also imagine or visualize representation of roles as a special hats that the users can wear or the services can wear for performing specific tasks. Okay, so next is moving on to benefits of using an IAM role. Let's talk about that. So some of the benefits of an IAM role could be, we can think of IAM role as a limited pseudo access given to someone to use the AWS. You can give and assign the roles to people, you can assign the roles to an application or even to the services. So if you're assigning the IAM role to people, it typically grants cross account access to employees. That could be one of the good use case. Or think of or think of using the role and using the identities in your current IDP to access the different resources. That means your identity provider can access the resources within the AWS account. Then next is the another good use cases. You can also assign an IAM role to the application. That is, you can permit an application running on AWS or in the on-premises to make any AWS API calls. You can make an API call to any AWS services. It could be EC2, it could be S3, or it could be anything else. Next is you can also assign an IAM role to a service. For example, if I want to make a call to an S3 bucket from my EC2, I can rather create an IAM role for an EC2, assign that IAM role to an EC2, and from within the EC2, I can then make a call to an S3 bucket. Okay, maybe I can fetch a data and I can access anything from the S3 bucket. All right, then next is moving on to policies in IAM. Now, what are the policies in IAM? So IAM policies, think of to be like a digital rule book. So policies in IAM act like a rule book for your digital space. They decide who can do what. That is your digital laws. So components of IAM policy include, they are made up of special language called JSON. It's like a blueprint that specifies the rules for access within your digital kingdom. So some of the examples of policy statement could include, policy statements are like specific rules in rule book. Let's take an example. You can have a rule saying user A can read but not edit. It's that detailed. So you can visualize a digital rule book with example statements laid out, okay, in the form of JSON. So that's all the policy is. All right, let's now spend some time and try to understand how the policy evaluation takes place. So when a principal tries to use an AWS management console, the AWS API or the AWS command line interface, that principal basically sends a request to AWS. And when an AWS service receives the request, AWS enforcement code decides whether the request could be allowed or denied. This is typically the summary of the AWS evaluation logic for policies within a single account. Let's talk about how this policy will be evaluated. So first, decision always starts with a deny rule. That means by default, nothing is allowed. It will evaluate all the applicable policies and then it will put up a decision tree here, okay, asking, is there an explicit deny? If it is, then final decision will be denied to the service or the denying for the task. If there's no explicit deny configured, then it will check, is the principal's account a member of an organization with an applicable SCP? SCP, by the way, stands for service control policies. Now, if there is an allow configured, then it will move on to the next step. or if there is a allow not configured, then final decision will be deny. That is an implicit deny. Okay, that's coming in from the organizations SCP, that is the service control policies. Now, if there's a allow list configured in the SCP, then it will move on further and it will ask another question. Does the does the resource have a resource based policy configured? If it is yes, then it will check, is there any allow list configured? If yes, then you can check and then it will grant the access to the particular resource based on the policy that's configured. But if there's no specific explicit allow configured, then we will move on further. The next question it will ask, does the principal have an identity based policy? If it is no, then final decision will be deny, and that's an implicit deny here. If it is yes, then we have another question to ask. Is there any allow list configured? If no, then final decision will be again denied. That's an implicit deny. And if it is yes, then we'll move on further. Next is we will be asking another question. Does the principal have a permission boundary? If it is, then do we have an allow list configured? If no, then simple answer will be deny, and that's an implicit deny. Okay, that comes in the IAM permission boundaries. If there's an allow list configured, then we'll move on further. We'll ask another question. Is the principal a session principal? That is, you are being allowed access via some session policy. That is an SDS policy. That is security token service policy. Okay, so if there's a principal, a session principal configured, then we will move on and ask a question. Is there a session policy? If no, then is this a role session? No, then final decision will be denied. If there's a session policy configured, then we'll ask another question. Is there an allow list? If no, then final decision will be denied. If there's an allow list, yes, final decision will be allow access. And now we'll move on to this part. If the principal, a session principal, no, then final decision will be allow. Okay. Now here also, I mean, there were few things we missed out. Is the principal account a member of an organization within an applicable SCP? If the account itself is not a member of an organization because it's a standalone account, then we will ask another question. Does the resource have a resource-based policy? If no, then again we'll move on. We'll ask another question. Does the principal have an identity-based policy? If yes, is there an allow list configured? Then we'll move on further. And that ways we can keep on moving. And this ways the entire IAM policy will be evaluated. Okay, next is over a period of time, you might have a lot of permissions assigned to the different resources to the different users. And it actually makes sense to keep reviewing these permissions over a period of time. So when a principal tries to use an AWS management console, the AWS API or the command line interface, that principal sends a request to AWS. And when the AWS service receives the request, AWS enforcement code decides the request should be allowed or denied. Okay, and it is actually very, very important. We should keep tracking these permissions or policies over a period of time. And that can be done in AWS IAM via some component called as Access Advisor. Now, this Access Advisor shows the data about the service permissions and last usage. That is, when was the last time this permission was being used. Okay, so take an example here. We have some service called AWS Billing, and here the permission assigned is billing team. And whether it was last access, yes, it was, and it was access last yesterday. So this ways you can keep track of the permissions and when were these permissions accessed last time. Now, finally, we have something called as an IAM best practices. Let's spend some time and talk about some of the IAM best practices. So always make sure that you use the least privilege principle and keep reviewing the accesses periodically. It's very important. always ensure to assign an MFA, that is multi-factor authentication, because having an MFA will ensure that only authorized person is allowed to access a AWS identity. Then you should also follow the guidelines for creating the strong policies. Okay, on always allow the principle of least privileges. So with this, I'm just concluding my topic. Okay, so we talked about that. Make sure that we talked about IAM is nothing but your guardian in the digital world. IAM is like a superhero of the digital world, managing who can access what. Then we talked about users, groups, roles, policies are nothing but the building blocks of an IAM, and each playing a crucial role in securing your space. Then we talked about reinforcing an IAM role. So IAM is not just a fancy term, it's your digital guardian, keeping your AWS resources safe and sound. Just like you trust a guardian to protect your home, IAM safeguards your digital kingdom. So always encourage your teams to follow the best practices to keep your digital fortress strong and follow the best practices. Make sure you regularly review and update the permissions and use the principle of least privilege and embrace multi-factor authentication. These are your keys to optimal security. Okay, so with this, uh, let's quickly run towards the demo and will then come to the conclusion part of this IAM. All right, now I'm going to quickly run through this demo and we'll talk about what exactly are we going to do as a part of this demo. Okay, now in this, we will be exploring a lot of things, especially about IAM service, then IAM users, groups, policies, and roles, and how to programmatically allow access to certain things. Okay, so now let's quickly jump on and we'll first go to IAM service. And remember, IAM is the service that is offered at no additional cost. Okay, some of the use cases could include with IAM, you can manage AWS permissions for your users and applications. And for your users, we recommend that you can also think of using something like the IAM Identity Center, which is a successor of AWS Single Sign-On. So, so that you can manage access to AWS accounts and permissions within those accounts. So AWS IAM Identity Center makes it easier for you to provision and manage the IAM roles and policies across your AWS organization. So for application permission, you can also use the IAM roles and policies to grant only the required access to your applications. Okay, so now I'm going to quickly search here IAM, that is Identity and Access Management. So I'm in the IAM, and remember, IAM service is global service. Okay, there's no region that has to be specified when creating an IAM. Okay, now with IAM, you can define who can access what and you with the fine-grained permissions and so on. Now, what are IAM users? We already talked about that. IAM user is an entity that you can create in AWS to represent the person or application that uses it to interact with AWS. A user in AWS consists of name and credentials. So imagine a user called Praveen. When you create the IAM user Praveen, you create a password for that user. You may also attach some permissions to that IAM user that will allow them launch a specific Amazon EC2 instance. Now, this particular thing, we will be creating the IAM user first, then we'll jump onto the groups as well. So we talked about the groups are nothing but the collection of IAM users. So user groups lets you specify the permissions for multiple users. Okay, and we can see these users, then we can see the user groups, and we can even see the roles here. Okay, fine. So now let's do one thing. Let's first create the IAM user. Okay, let's create the IAM user and we can assign the user some permission. Okay, so first off, I will jump onto the users and let's create one user account here. So I'm going to click add user, and then what we'll do here is we will assign this user some name. Praveen. Okay, next is it's asking, do you want to provide user access to the AWS Management Console? Yes, we definitely want to do that. So I'm going to select this, and then it's asking, do you want to specify the user creation in Identity Center, or do you want to create a user in the IAM, that is the Identity and Access Management? So we will say, I want to create an IAM user at the moment. Identity Center is something we will be exploring later on in some other sessions. But for now, let's create a user in the IAM, and we can also assign some custom password, or we can let it auto generate my password. So let me assign some custom password here. And then we will click next. We can also say user must create a new password at the next sign. Or if you prefer, you can uncheck this, and then you can you don't need to necessarily reset the password at the first sign in. So let me click next, and then it's asking, do you want to assign some permissions to this user? Let's assign some permissions. Now there are three ways by which you can assign the permission. First is you can add the user to the group, and whatever permissions are assigned to the group, user will be getting that permission. Second is you can also copy the permissions from an existing users, or you can also set your permissions boundary. Okay, so you can define the permissions boundary till what level of access the user is allowed. Or alternatively, if you prefer, you can directly use the readily available permissions. Or if you feel that these permissions policies are not good enough, maybe I want to granularly control access to the resources to the user, that also you can do that. That ways you can also create your own policy. Now, AWS has a very excellent tool called as AWS Policy Generator, which you can always use it and you can create your own set of policy. So let me quickly show you that AWS Policy Generator tool. Now, this is a fabulous tool that I normally use it to create my own set of policies. All right. Now, next is at this moment, I'm going to just assign the permission called administrator access. That means I'm assigning full permissions to this particular user at the moment. All right, I'm going to click next. And finally, we will go ahead and create this user. Perfect. So at this moment, our user account has been created. Now, next thing is we will go ahead and log in with this user account. Now, in order to log in with this user account, you can always copy the console sign-in URL. All right. Or you can also do one thing. You can download the CSV file, which consists of this console sign-in details along with username and the password that you can use it to log into the console. So let me copy this console login URL, and it's recommended don't try to open in a new tab, but rather use an incognito window. Okay, which I'm going to do that, and I'm going to log in with this account, the account that we have created at this moment. That is a account username Praveen. Okay, next is I'm going to assign the set the password, which we have already set it up earlier. And let me log in with this account. Cool. So we are now able to log in with this user account. Okay, so what we have done so far is we have created one user account in the IAM console, and then we set some password for that user account. We assign the policy to the user. All right. And then we try to log in with that user account using the console login URL. In that ways, we are now able to access that user account. Okay, now what next? Next thing is we can create groups, we can create the roles, we can create the policies. Let's quickly explore those options as well. All right, so now since we have created the user account and we have already logged in with that user account, the next step is always ensure that we have a MFA configured for that user account. Now, since we have already assigned the administrator privileges to this user account, so that means this user account is having the highest privileges. Okay, so in order to protect this user from any unauthorized access attempts, we should always ensure that we should assign the MFA for this user account. So let's do that. Let's configure an MFA for this user account and we can see how we can move on with this. So in order to assign an IAM MFA for this user account, I'm going to select the user account and under that, I will select security credentials. Okay, under security credentials, we can select the user account that we have already created, that is Praveen, and we can assign the MFA under the security credentials here. So let me do that. Let me assign the MFA device for this user. Now here, there are three ways by which you can assign the MFA device. First is using the Authenticator app. So this is the one that you can install it on a mobile device and you can configure the MFA. Second is using the security key. So you can purchase this YubiKey or Fido security key from the Amazon marketplace and you can always enable the MFA with this device. That is a security key device. Or you can even purchase the hardware TOTP token and you can also activate the MFA. So using these security keys or hardware TOTP token are considered more secure. All right, so I'm going to choose the Authenticator app at the moment since I don't have that option. So I'm going to go with the Authenticator app. Cool. So then you can also assign the device name, something like my first device, where you're activating the MFA for this user account. Then you click next. Now it says, all right, the MFA device already exists. We are going to say add MFA. Okay, let me check if the MFA device already exists for this user account. All right, so looks like that MFA device name was already existing. Hence, I was not able to move further. So what I did is instead of that name, I have given number one as an additional thing. And then I was able to move further. Okay, next is you have to show this, click on show this QR code. Okay, and you have to configure, you have to install one of these mobile apps, that is Google Authenticator, Duo Mobile, or Authy app as one of the um, available options. All right, so you can click on show this QR code and then you can scan this QR code with your Authenticator app. So let me do that. So I have my Authenticator app here. I'm going to click next. And let's configure MFA with this mobile app. So this is one of my Authy app with which I'm going to activate the MFA. So let me quickly scan this QR code by clicking on plus sign there, and I'm going to scan this QR code. Okay, so I was able to scan this QR code and then I will enter the first 6 digits that appear on that app. Then I'll have to wait for a couple of minutes until that 6-digit code gets expired. And then I have to enter the second 6-digit subsequent code. Okay, so I was able to get that and let me click on add MFA. Once you're done, you are now able to activate the MFA with your account. So with this, we are able to now secure this account. Cool. Awesome. So now let's move on further and we'll move on to the next part of our demo. So we have been able to activate the MFA for this particular user account, which means we have been able to secure this account. Now moving on further, let's quickly explore the groups. So as I mentioned, groups are collection of IAM users. So user groups let you specify the permissions for multiple users, which can make it easier to manage the permissions for those users. For example, you could have a user group called admins and give that user group the type of permissions that typically administrators will need. So any user in that user group can automatically have the permissions that are assigned to that user group. Okay, so let's quickly do one thing. Let's create a user group and then we can manage the permissions for that user group and we can assign the permissions as well. Okay, so we are going to create a new user called power user first. Okay, I'm going to click next. Here at this moment, I'm not going to assign any permissions to this user. So I'm just going to create a user, that's all. Okay, next off, what we'll do, we'll create a group called developers. Okay, so let me go ahead and do that and let me create the developers group. Okay, and now we will select this user, power user, and we will be adding this user to this group. Okay, now in terms of permissions or policies, we will assign EC2 full access to this particular group. Amazon EC2 full access. All right, and we'll create the group. Awesome. So now we have been able to create user, that's a power user, and then we created a group called developers. We added that user, power user, to the group called developers, and we assigned the permissions to the group, that is Amazon EC2 full access. So that means whichever users are part of this group, developers will be able to get that permissions. Awesome. So now let's move on, and we have been able to create the group. We have been able to see who are part of these groups. We have been able to see the permissions as well. Let's take a look at this once. So I'll open the developers group. And as we can see, there's a user called power user who's part of this developers group. And what permissions are assigned to this? The permissions that are assigned to this group is Amazon EC2 full access. Let's take a look at this permission as well, that what permissions are assigned here. So this is in terms of how the permissions are assigned. All right, so this particular group has got Amazon EC2 full access, and that grants CloudWatch full access, EC2 full access, EC2 auto scaling full access, ELB, that is the load balancer full access, and ELB V2 full access. In addition to that, that also grants some limited write permissions to an IAM. All right, so that's all the permissions are assigned to that policy called Amazon EC2 full access. Cool. So with this, we have explored the concept of groups. Let's now jump on and we'll try to understand a little bit on the IAM roles. So IAM role is an identity with permissions policies that determine what the identity can and cannot do in AWS. However, a role does not have any credentials like password or access keys associated with it. Instead of being uniquely associated with one person, a role is intended to be assumed by anyone who needs it. An IAM user can assume a role to a temporarily take on permissions for that specific task. A role can be assigned to a federated user who's not there in your AWS, but is there in some different identity, who can sign in by using his external identity provider instead of an IAM. So AWS also uses details passed by the identity provider to determine which role is mapped to that federated user. All right. And as I mentioned, this is basically a special hat that the users or services can wear. Okay. And they can then perform those set of tasks. All right. Now let's quickly explore how to create an IAM role. Okay. So I'll just go here under the roles here, and we can see there are some roles which are already pre-created by Amazon. Okay, so these are there for some specific purposes. That's why they have created these roles. Now we are going to create a new role here by clicking on create role. Now here we will select the AWS service or an AWS account or a web identity or a SAML 2.0 federation in the event you are allowing an external identity provider access to your AWS accounts. Okay. Or you can even create a custom trust policy, and you can create a role and assign that policy to this IAM role. So at this moment, our use case is involving the EC2. So I'm going to select this IAM role for EC2. We'll click next, because right now we are creating this IAM role for EC2, so that from EC2 we will be able to make a call to the S3 service. Okay, and we can perform any download objects or create objects or delete objects permissions. Okay, so what I'm going to do in terms of permission policies for this IAM role, I'm going to search for S3 full access. And let me select this permission, S3 full access, and then I will click next. Cool. So now we are going to give the role name EC2 S3 full access. That means this role is created for an EC2 in order to grant S3 full access to an EC2 instance. Okay, next off, you can assign the tag if you prefer to, but right now we will not do that. We will simply go ahead and create this role. Okay, so now we have been able to create this role. Now, if you want to view this role, you can either come back to the roles, or you can even click on the view role option in order to view this role. And there you go. You can see we have got this role created, and the permissions assigned to this role are Amazon S3 full access. The trust relationship is for EC2. So that means we are basically assigning this permission or assigning this IAM role for EC2. That means our EC2 instance will be assuming this role, and then will be able to make a call to our S3 service. Okay, now what is this trust relationship? It is a list of entities which can assume this role. So over here, as you can see, EC2 is the list of entity which can assume the role. Then there could be many more other entities which can also assume the role. An entity must be specified for the role to be assumed. So when you use the AWS directory service to create a role using the procedure in the creating a new role, this trusted relationship is automatically set. So you only need to establish this trust relationship for the IAM roles that are not created by the AWS directory service. The relationships are listed as JSON policy documents. As you can see, this is how the JSON policy is written. Okay, this is a JSON policy document in which you define the principle that you trust to assume the role. So principles that you can specify in the trust policy include your users, roles, accounts, and services. So if an account is specified, any users associated with that account can assume the role. All right, so that's all. Congratulations, we have been able to explore the concept of roles here. Now, policies, as I mentioned, these are nothing but the JSON documents, JSON policies. Okay, it's written in the JSON language, and you can see, take a look at this one of the permission policy that's already pre-created by Amazon. So if we click on JSON, this is all the set of permissions that are assigned for this particular policy, administrator access, and it's again written in the JSON. Now, if you feel you want to create more granular role by assigning the more granular permissions, you can do that. You can write these permissions in the JSON form using a tool called AWS Policy Generator. So with this, I'm just coming to the end of our demo. Hope you have enjoyed this demo. So thank you so much for tuning in today. And I hope you enjoyed the insights and discoveries shared in this video. And if you found it valuable, don't forget to hit that subscribe button and join our growing community. Your support means the world to me, and I cannot wait to share more exciting contents with you. Until next time, stay curious, stay connected, and let's explore the wonders of technology together. And thanks again. See you in the next video. Have a wonderful day, guys.